Watch the belly of a Boeing 737 right after takeoff and you'll see something that looks wrong. The main wheels tuck up into the fuselage, but the tires never fully disappear. Two wide black stripes of rubber sit there, exposed to 200-mile-an-hour air, like the plane forgot to finish closing itself up. Passengers snap photos of it through the window all the time, convinced they've spotted a fault nobody else noticed. That gap isn't a defect. It's not something Boeing quietly ignored for almost 60 years of updates. Every 737 built since the first prototype rolled out of Renton, Washington in January 1967 leaves its main wheels hanging out in the open, on purpose. Understanding why means going back to an airport that never had a jet bridge, and a decision Boeing has never fully undone. In 1964, Boeing needed an answer to the McDonnell Douglas DC-9 and the British BAC-111, both of which were already carving up the short-haul market. The plan was a compact twin-engine jet that could handle routes the bigger 707 and 727 were too large and too expensive to fly. Lufthansa signed on as the launch customer in February 1965 and pushed Boeing to grow the cabin from a modest 60-seat regional hop into something closer to 100 passengers. The first 737-100 prototype took its maiden flight on April 9, 1967, was certified by the FAA that December, and entered airline service with Lufthansa on February 10, 1968. But the routes Boeing was actually chasing weren't Frankfurt or Chicago. They were smaller cities and secondary airports across Europe and the United States, places without jet bridges, without high-lift cargo loaders, sometimes without much more than a runway, a fuel truck, and a handful of ground staff. So Boeing's engineers made a decision early on that ended up shaping nearly everything else about the airplane. They built it low enough that baggage handlers could load and unload the cargo hold by hand instead of renting specialized lift equipment. Low enough that mechanics could reach the engines and service panels standing flat on the tarmac. Low enough that passengers could walk up the 737's own built-in air stairs instead of waiting on a jet bridge the airport simply didn't have. That single choice, keeping the fuselage close to the ground, is the entire reason the wheels are still visible today, more than half a century later. A low fuselage means short landing gear legs, and short legs mean a shallow wheel well. A shallow wheel well leaves almost no room for the kind of large, hinged doors you'd see swing shut underneath an Airbus A320 or a Boeing 787 after the gear retracts. To fully enclose those main tires, Boeing would have needed doors big enough to cover a wheel roughly 4 feet across, doors that had to open on approach, seal shut in flight, and never once jam in between. In the 1960s, hydraulically actuated gear doors were exactly the kind of moving part that broke down, and they broke down hardest at the small regional airports the 737 was actually built to serve, the ones without a hangar, a parts shelf, or a line mechanic on call around the clock. So Boeing skipped the doors entirely and engineered around the gap instead. Each main wheel got a smooth metal hubcap bolted onto its outer face, shaped to blend into the curve of the fuselage, and a rubber seal wrapped around the opening of the wheel well that presses flush against the tire once it folds up inside. The moment the wheels leave the runway, the brakes clamp down automatically to stop them spinning before they tuck into that opening, so the tire isn't still turning when it meets the seal. Pull the hubcap off during maintenance and forget to put it back before a flight, and the airline genuinely pays for it, in extra drag and a small but measurable knot or two of lost cruise speed. It's not a perfect fix, and it was never meant to be. The wheel well still sits wide open on the ground and throughout takeoff and landing, catching runway debris in a way a fully enclosed bay never would. Boeing's engineers weren't chasing the smoothest possible belly. They were chasing something a two-person maintenance crew, working outdoors with hand tools, could keep flying without anything breaking. You'll find the same trade-off on regional jets built decades later, like the Embraer E-Jet family and the ATR turboprops, aircraft that share the 737's problem of very little ground clearance to work with. As the gear retracts, each main strut rotates inward and slightly aft, folding the wheel up into a wedge-shaped bay tucked between the wing and the belly. No separate door needs to swing out of the way first, no second hydraulic circuit needs to fire on cue. Fewer moving parts means fewer things a mechanic has to inspect on every check, fewer hydraulic lines routed through a tight space, and less weight carried on every single flight for the life of the airframe. Multiply a few £100 of saved door hardware across the entire 737 production run, and the fuel savings start to look like a serious argument, even if it's one Boeing rarely gets credit for. Not everyone in aviation loves the trade-off, and it's fair to push back on it. Engineers who work gear systems for a living will point out that an open wheel well is still an open wheel well. Boeing's answer has always been that the difference is small enough and the reliability gain large enough that it simply isn't worth solving with more machinery. That trade-off might have made complete sense in 1968. What's harder to explain is why it's still true on 737s being assembled this year. The answer is that every 737 built since the original 100 series shares the same type certificate the FAA first issued on December 15, 1967, amended again and again over the decades rather than replaced outright. The 737 Classic in the 1980s, the Next Generation in the 1990s, and the MAX starting in 2017 are all, on paper, still the same basic airplane the FAA signed off on nearly 60 years ago. Keeping that lineage intact isn't sentimental, it's financial. It's the reason a pilot who trained on a 1990s Next Generation can climb into a brand new MAX after a few days of differences training instead of a full-type rating that can take weeks and cost real money to complete. Airlines like Southwest and Ryanair built entire fleets, crew schedules, and pilot pipelines around that shared type rating. Redesigning the landing gear enough to finally fit real doors would mean cutting into the fuselage cross-section the wheel wells are built into, and that risks pulling at the thread. The whole certification lineage has been stitched to since 1967. There's a parts and maintenance argument too, one that only gets stronger with time. Boeing has delivered more than 12,000 737s since that first Lufthansa aircraft, and a huge share of them share this exact wheel well, this exact hubcap, this exact seal. Every airline maintaining a 737 fleet stocks the same gear components, trains mechanics on the same procedures, and writes the same maintenance manuals regardless of whether the airplane rolled off the line in 1985 or last month. Redesign the gear now, and every one of those advantages resets to zero for a feature that mostly bothers people scrolling window seat photos online. That same low ground clearance quietly reshaped almost every later 737 generation in other ways too. As engines grew larger and more fuel-efficient, Boeing had to flatten the bottom of each new engine nacelle just to keep it from scraping the runway, since there was never enough room under the wing to hang a bigger, rounder engine the way Airbus could on the taller A320. The exposed main wheels aren't just a leftover quirk sitting on their own. They're one visible piece of a much longer chain of compromises that all trace back to a decision about ground clearance made before anyone on the original project had ever touched a computer to design an airplane. Even the newest 737 hasn't fully escaped it. The MAX 10, the longest version Boeing has ever built, needed a taller landing gear just to keep its stretched tail from scraping the runway during takeoff rotation, so engineers added a trailing link design that lets the gear extend a few extra inches at exactly the right moment. As of mid-2026, the MAX 10 is in the final stage of FAA flight testing, with certification expected later this year, and first deliveries now pushed into 2027 for launch customer WestJet. But even with a taller, more sophisticated gear leg underneath it, the wheels themselves still sit out in the open, still wearing the same style of hubcap and rubber seal Boeing engineered for regional airports that mostly don't look anything like their original 1960s selves anymore. Almost 60 years after the first prototype left Renton, the jet bridges Boeing designed around have shown up nearly everywhere. The airplane never got the memo, and honestly, it never really needed to. So the next time you're in a window seat and the gear folds up after takeoff, that strip of exposed rubber isn't a warning sign. It's a fossil, a piece of 1960s engineering logic still doing its job on an airplane built decades later.